doing an introduction to Le Chatelier's principle. Le Chatelier's principle is a fundamental concept in chemistry that helps us predict how chemical reactions will respond to changes in conditions. It states that if a system at equilibrium is subjected to a change in temperature, pressure, or concentration of reactants or products, the system will shift its position of equilibrium in a way that counteracts the change. This principle is important because it allows chemists to control chemical reactions by adjusting the conditions in which they occur. For example, if we want to increase the yield of a product, we can use Le Chatelier's principle to predict how changing the reaction conditions will affect the equilibrium position and then adjust those conditions accordingly. What is the equilibrium constant? The equilibrium constant, also known as Kc, is a measure of the extent of a chemical reaction at equilibrium. It is defined as the ratio of the concentration of products to the concentration of reactants, each raised to their respective stoichiometric coefficients. The value of Kc is constant for a given reaction at a specific temperature and pressure, regardless of the initial concentrations of the reactants and products. Kc is closely related to Le Chatelier's principle, which states that a system at equilibrium will respond to any stress in such a way as to counteract the stress and re-establish the equilibrium. If a stress, such as a change in temperature, pressure, or concentration, is applied to a system at equilibrium, the system will shift in the direction that minimizes the stress. The value of Kc remains constant, but the concentration of the reactants and products will change to maintain equilibrium. So what factors can affect equilibrium? Equilibrium in a chemical reaction is affected by several factors like temperature, pressure, and concentration. Le Chatelier's principle can be used to predict the effect of these factors on equilibrium of a chemical reaction. Temperature affects the equilibrium constant of a reaction, with an increase in temperature favoring the endothermic reaction and a decrease in temperature favoring the exothermic reaction. Pressure changes affect the equilibrium of reaction involving gases, with an increase in pressure favoring the side with fewer moles of gas. Concentration changes also affect the equilibrium of reaction, with an increase in concentration favoring the reactant that consumes the added reactant. When it comes to chemical reactions, temperature changes can have a significant impact on equilibrium. According to Le Chatelier's principle, if you increase the temperature of a system at equilibrium, the reaction will shift in the direction that absorbs heat, the endothermic reaction. This means that the endothermic reactions will be favored when the temperature is increased, while exothermic reactions will be favored when the temperature decreases. Conversely, if you decrease the temperature of a system at equilibrium, the reaction will shift in a direction that releases heat. This means that the exothermic reaction is favored. Understanding how temperature affects equilibrium is important for predicting the outcome of chemical reactions and designing efficient processes. Changes in pressure can also affect the equilibrium of a chemical reaction. According to Le Chatelier's principle, an increase in pressure will shift the equilibrium towards the side with fewer moles of gas, while a decrease in pressure will shift the equilibrium towards the side with more moles of gas. For example, consider the following reaction. This reaction has 4 moles of gas on the left-hand side and 2 moles of gas on the right-hand side. If the pressure is increased, the equilibrium will shift towards the side with fewer moles of gas, which is the right-hand side. This means that the concentration of NH3 will increase, while the concentration of N2 and H2 will decrease. Changes in the concentration of reactants or products can affect the equilibrium of a chemical reaction too. According to LCP, if the concentration of one substance is increased, the system will shift towards the side with fewer moles of the substance in order to restore equilibrium. Similarly, if the concentration of one substance is decreased, the system will shift towards the side with more moles of the substance. For example, consider the same reaction. The concentration of nitrogen gas is increased. The system will shift towards the right in order to consume some of the excess nitrogen and produce more ammonia. Conversely, if the concentration of ammonia is increased, the system will shift towards the left in order to consume some of the excess ammonia and produce more nitrogen and hydrogen gas. I hope you enjoyed today's introduction to Le Chatelier's principle, and I know we'll learn a lot more about it in our coming lessons.